All right, so these are really important definitions I need you to know. So let's first look at the definition of onto. So I've drawn a picture of not onto and a picture of onto. All right, so when a mapping, a transformation, which is just the matrix multiplication, it's onto when all of the codomain, and so the codomain is here, is the range. So that means everything in the codomain gets hit from different vectors that are in the domain. So everything over here has an x that goes to it. Let me say that again. So it always starts in the, it's important to note that this definition, it says first, take a vector in the codomain. So pick something in here, pick a vector in here, and then you determine whether there's an x or something from the domain that goes to it. Then it refers back to the domain. So this is a picture of a mapping not being onto. So I can find a vector here that there's no x going to it. There's no x being mapped to it, right? X's are always in the domain. So the range does not equal the codomain when it's not onto. When it is onto, the range is the codomain. So the range are the things that are hit by the transformation. So here's a picture of just this piece of paper in this cube. So this would be the range, and it's not equal to the codomain. All right, let's move on to the definition of one-to-one. So again, we have the mapping. It's one-to-one if every vector in the codomain, notice we're starting here, every vector in the codomain is the image of at most one vector. So not every vector not everything has to be hit. So I could have this vector B here, right? This column vector B in the codomain that's not being hit, but every one that is here that has been reached, it has only one x going to it. This vector, this column vector here has one x going to it. So this is a picture of one-to-one. This is a picture of not being one-to-one. So I've drawn three different column vectors in the domain that all go to the zero vector. So this is not one-to-one because this one vector in the codomain has more than one vector going to it. So make sure you're really comfortable with these two definitions. So thinking about it, look, I even kind of made an emphasis of this. So you see how I have three different vectors going to the zero vector. You know, if I'm putting in the zero vector, this is the trivial solution. The trivial solution is always there, right? That the zero vector is going to the zero vector. The zero vector is going to the zero vector. That's always happening. That's trivial. But it's one-to-one if only, if and only if, the only solution to the AX equals 0 or the transformation to 0 is the trivial solution. And if it is one-to-one, then the columns of A are linearly independent. And then the columns of A are linearly independent if there is a pivot in every column. Whoa, lots there. Need to memorize all those things. All right, so let's think back onto the definition of onto. So onto means I can reach every vector in the codomain, right? That's the range. If I can reach every vector, that means that that means it's onto. That happens if and only if the columns of A span Rm. Span can get everywhere, so that means there's a pivot in every row. Another really important theorem to make sure you memorize. All right, so let's move on and dig into some problems about this. So here we have a matrix, or we don't know the matrix A. We want to try to find the matrix A that has this as the transformation. So let's write out what that means, right? So what this means is x1 plus 4x2, 0, x1 minus 3x2, x1. I want to make sure you're really comfortable that this is what the transformation is. Okay, so how can we find the matrix A? So I need to find out what it is that I would multiply times x1 times x2 to get this matrix, right? I want to make sure you're really comfortable with this. Okay, so let's find out this matrix A. So it's got to be 1, 4. So when I do matrix multiplication, right, this times this, I get this. Then I need 1, 0, and no, 0, 0, 0, 0, oops, sorry. And then 1, negative 3, and then 1, 0. All right, so now so that's my matrix A. So let's look at this matrix. I'm going to pull it over here. So I have 1, 4, 0, 0, 1, negative 3, 1, 0. Okay, that's my matrix A. So I'm looking at this matrix, and I want to determine whether the mapping is 1 to 1. So I need to do reduced row echelon on this, and I think I can do this with just manually. You could put it into your calculator as well, but if I do reduced row echelon on this, I get 1, 0, 0, 1, 0, 0, 0, 0. All right, so if it's 1 to 1, there has to be a pivot in every column. There is a pivot in every column. Pivot in every column. Therefore, this mapping is 1 to 1. All right, the next question is this mapping onto? If the mapping was onto, this matrix A would have a pivot in every row. So it is not onto. There's not a pivot in every row. All right, so let's do one more. So I'm looking at this matrix again. We'll be looking for the commas. So this is the first row and that's the second row, right? So AX would equal x1 minus 5x2 plus 4x3, and then x2 minus 6x3. All right, so I can see that this is going to be the same thing as if I want to think about what the matrix has to be. What does A have to be to multiply times x1, x2, x3 to get this? I'm going to have a 1, negative 5, 4, and a 0, 1, negative 6. There's my matrix A. All right, so the next question is this mapping 1 to 1? So I've already got it. If I just look at the matrix A here, I've got it is in echelon form, not reduced echelon form. So I could work it to get reduced echelon form. So I would get this 0, 1, negative 6. Okay, so that's the matrix A I'm looking at. So is this matrix does this mapping 1 to 1? It is not 1 to 1 because there is not a pivot in every column. So how about onto? Is this mapping onto? Yes, it's onto because there is a pivot in every row.